Supermassive black holes are the kind that have 1,000,000 to 1,000,000,000 times the mass of our sun. So these are the really massive galaxies. We think there's one in the center of pretty much every big galaxy, like the Milky Way, and bigger ones and smaller ones. So supermassive black holes, when they have a lot of stuff, when they're growing, when they're actively feeding, they have a lot of stuff flowing in through an accretion disk onto the black hole. And that stuff, as it falls toward the black hole, gets hot, super hot, to the point where it emits at really high energies, so X-ray, gamma rays. And these hot accretion disks are so bright. So just to say that again, this is mass outside the event horizon, so it's still able to let photons out. So it's bright, it's not stuck inside where the photons can't get out, but it's all this mass that's swirling around the outside of the event horizon of the black hole. It gets so hot and so bright that we can see these objects all the way out to the edges of the observable universe. So we can see them out at redshifts of 7 or 8, and this is way back when the universe was really young. And when we study that radiation from the heat and the photons coming off of this material as it tries to flow in toward the black hole, we can see that the mass at the center is already enormous. It's already millions or billions of times the mass of our sun. And so the mystery for supermassive black hole scientists is, how did you get something that massive so early on in the life of the universe? It means you had to get all that mass down into a black hole at very early times. So one way you can make black holes, the smaller kind, is you explode stars and the star collapses back down and it can give you a black hole. But those black holes are only maybe 10 or 30 times the mass of our sun. So if you want to build take building blocks of 30 solar mass things and build up to 1,000,000 solar masses or 1,000,000,000 solar masses, you'd need, 1,000,000,000 or 1,000,000 of those objects to crash together in LIGO-like mergers. And we don't think that's very likely. That would be a whole lot of stars exploding. We would see all these starbursts all over the edges of the universe. Or you could just force mass in there really fast, but it's hard. We don't have a good physical model for how you can get so much mass into a black hole so early in the life of the universe. And so that's a mystery I would really love to work on more, to think about the formation of black holes in the very early universe, and then how they evolve as we move toward the present day. And we're only now just getting a kind of new generation of space telescopes that can allow us to probe black hole growth way at those early times. It's hard work, it's very finicky. The galaxies they live in are small, and sometimes this bright, hot gas around the black hole just sort of outshines everything else, and it's really hard to see the environment and to understand what the building blocks were that gave you that supermassive thing just really fast. They basically grew really fast, and we don't know how they could possibly grow that fast.